In the world of AI, progress doesn't really move in a straight line. Sometimes you get a whole year's worth of breakthroughs crammed into a single week. And last week was absolutely one of those moments. A series of advances so big, they're starting to redefine what's even possible in science, security, and, the entire economy.
So to get us started, let me just ask you this. For half a century, one of the fundamental speed limits in all of computing has stood completely unchallenged. A record set by a human way back in 1969. So how do you finally break it? Well, the answer is you don't. You build something that can.
All right, so here's what's on deck. We're going to start with AI's incredible new cognitive leap, then see how it's literally rewriting science and medicine right before our eyes. After that, we have to look at the peril, because the whole ecosystem is under attack. Then we'll cover the race to build some guardrails, and finally, the trillion-dollar engine that is powering this whole crazy ride.
Okay, first up, AI's new cognitive leap. Look, the big story this year isn't just about making these models bigger. It's about making them fundamentally smarter, way more efficient, in ways we're really just starting to wrap our heads around.
And this right here is the perfect example. Remember that 50-year-old record I mentioned? It belonged to something called the Strassen algorithm for matrix multiplication, which, trust me, is a cornerstone for everything from video game graphics to the very AI models we're talking about. Well, this week, Google DeepMind's AI, AlphaEvolve, just went and discovered a brand new algorithm that's even faster. The AI didn't just solve a problem we gave it, it found a better way to the solution that no human had managed to find in 5 decades. Insane.
That's a huge theoretical breakthrough, for sure. But this revolution is also happening on the engineering level. It's one thing to have a brilliant idea. It's a whole other thing to make it actually work efficiently out in the real world.
Just look at this. This shows you the clever new architecture behind a model called DeepSeekV3. Look at the massive difference between those two bars. Think of parameters as neurons in an AI's brain. So, DeepSeek has this enormous brain with 671 billion of them. But because of this new design, it only needs to light up a tiny fraction, just 37 billion, for any given task. It's kind of like a genius who can achieve perfect focus, giving you top-tier performance while using way less energy.
And all that efficiency and power, it's translating into real-world dominance. In the super complex world of software engineering, Anthropic's Claude 4 Opus just grabbed the crown. It smashed the notoriously difficult SWE benchmark with a 72.5% score. And get this, it has a 200,000 token context window. That's like being able to read and remember a 150-page book in one go. It can understand huge, messy code bases. This thing isn't just a coding assistant anymore. It's quickly becoming a full-on coding partner.
So, with these ridiculously powerful new models, what can we actually do? Well, that leads us right into our next section, rewriting science and medicine. AI is moving past being just a tool, it's becoming a core collaborator in scientific discovery itself.
Check this out. The pharma giant Eli Lilly and the chipmaker NVIDIA just announced they're teaming up to build a dedicated supercomputer. Its one and only job to run AI models that discover new medicines. They're calling it a drug discovery factory, and it's designed to quadruple the scale of what's possible, just sifting through millions of potential molecules to find life-saving drugs.
And in biology, the legendary AlphaFold just got a massive upgrade. The new version, AlphaFold 4, is a total game changer. Figuring out a protein's 3D structure used to take weeks of painstaking lab work. Now, it takes minutes of computation. And the accuracy is so sharp, it's actually on par with doing physical experiments. This is accelerating biological research at a pace we have just never seen before.
And it's not just about finding cures, it's about predicting illness before it even happens. A new model called Delphi 2M was trained on huge healthcare datasets, and it can analyze a person's medical history and predict their risk for over 1,000 different health conditions decades into the future. This could completely flip public health on its head, from a reactive system to a proactive one that's all about prevention.
But, and you knew there was a but, with all this incredible progress comes a pretty harsh reality. Every powerful new tool creates a powerful new weakness. And this brings us to the peril. The entire AI ecosystem is under constant attack.
This week, researchers revealed a vulnerability in Salesforce's AI agent called Forced Leak. It got a severity score of 9.4 out of 10. Now, just for context, anything over a 9 is considered critical. This bug allowed attackers to basically trick the AI into leaking sensitive user data using something called indirect prompt injection.
And that right there is the core of the problem. You see, security experts are all starting to agree. Prompt injection isn't a bug you can just patch and forget about. It's a fundamental, basically unavoidable vulnerability. As long as these AIs are connected to the internet, processing data we don't control, they can be manipulated. It is a system-level crisis for the entire industry.
So, if the threat is truly inevitable, what's the response? Well, that takes us to our next chapter, building the AI guardrails. The race is on, right now, to create the safety frameworks we desperately need to manage these powerful systems.
Since you can't just eliminate the threat of prompt injection, the strategy has to shift to containment. So think of it less like patching a software bug and more like building a much smarter fortress. The industry and governments are now focused on building bigger, more intelligent walls to defend these AI systems.
And this new reality? It's now official. It's formalized in the US government's own taxonomy of AI threats. The brand new 2025 report from NIST has been expanded to formally track things like prompt injection, risks from autonomous agents, and vulnerabilities in the AI supply chain. These are no longer just theoretical problems. They are official, named adversaries. And accountability is starting to creep in too. The Future of Life Institute just dropped its AI Safety Index. It's an independent audit of 7 of the top AI labs, grading them on 33 different indicators of responsible development. This kind of external pressure is creating a new standard for transparency and basically forcing these companies to prove they're committed to safety.
Now, all of this, the incredible progress, the scary peril, the frantic race for safety, it's all happening at lightning speed for one main reason. And that brings us to our final section, the trillion-dollar AI engine. This whole cycle is being fueled by an absolutely unprecedented tidal wave of money.
So, this week, OpenAI closed a share sale that valued the company at $500 billion. Just let that number sink in for a second. $500 billion. I mean, that is just a staggering valuation that shows you the immense expectations riding on this technology.
And here's why that number is so crucial. With this new valuation, OpenAI just blew past SpaceX to become the single most valuable private company on Earth. The market is now officially betting that the future of artificial intelligence is even bigger than the future of private space exploration.
And that money is being turned into raw power almost instantly. OpenAI also just announced a multi-billion-dollar deal with AMD for 6 gigawatts of AI infrastructure. To put that into perspective, 6 gigawatts is enough electricity to power millions of homes. This isn't just buying some computer chips. This is building compute power on the scale of a small country, all dedicated to training the next generation of AI.
Okay, so we've covered cognitive leaps, medical revolutions, critical vulnerabilities, and trillion-dollar economics, and all of that happened in just 1 week. The future isn't arriving in years anymore. It's arriving weekly. If you want to have any hope of keeping up with this incredible pace, make sure you're subscribed to Nexus Tech. So we end up right back where we started, with a question. We are building systems with cognitive abilities that can shatter 50-year-old records, and we are backing them with literally trillions of dollars in investment and infrastructure. So really, the only question left is, what happens next?